Hello and welcome to lesson 4.2. Today we're going to learn about what to do with categorical variables. Now categorical variables are a little bit more difficult to work with because we can't easily, we don't have an easy number that we can describe them with numerically. Um, what we do is we put them into two-way tables like this. Now to complete the two-way tables, what we need to do is find the totals on the column and totals on the row. So, so if we add all of these up, so the total here would be 150, just adding it up horizontally. I can add these up, and these up. So hopefully you have a note sheet in front of you so you can fill in all of these numbers on the table. So pause it. All right, now the answers are right here. Actually, these aren't the answers. I forgot there's one thing that's wrong. This should be an 8. All right, now age groups are the row variable because they're described in the row. Sex is the column variable. Uh, now, these are called marginal values because the totals are written in the margins of the data. Now, we can do this again, but if we do, we can, sometimes instead of these numbers, what we want to do is have percents. So I'm going to take each of these values and we erased those values, and so now if what I can do is make this not with counts but with percents. So if I use percents, what I'm going to do is take 89 over 16,638, and if I did that, my answer is 0.0054. So it's about 0.5%. To find the male, what I'm going to do is take 61 over 16,338, and that answer is about 0.4%. Now take a second, pause the video, and fill in the rest of these answers. All right, hopefully you were able to fill in the data with the percentages, and this is the data that I found. Now, you can see that when I added up my totals, they only came up to 99.9%. Now, when I did that, it should add up to 100%, but there had to be some round-off error. So we just call this, we just say that there was some round-off error when I was finding these percents. It should equal 100%, but if there's some error, some round-off in there, it can be a little off. All right. Marginal distributions are the row and the column distributions. Marginal distributions are often given in percents, like with the one we just did, and marginal distributions do not tell us about the relationship between the variables. Now we can do that again with the number of concussions. We can take these number of concussions, do the totals on each of the columns, and we could also do it again using percents. So if you need more practice with this, take some time, fill those in. The next thing we should do is conditional distribution. It's the distribution given that one certain condition is met. So in this situation, we're assuming that the percent of 18, that we're talking about only the percent of people who are 18 to 24 years old. And we want to figure out, of this group, what percent is female and what percent is male. So if I go back up to my original set of data, but of which I erased. Here, I'll get it back. Oh, it was on the next page. There it is. Wonderful. This is what I want. So if I look at this, in this group, there are 10,365 people. The percent that are female are 5,668 over 10,365. The percent that are male are 4,697 over 10,365. So it's going to be close to some like 50, 6 and 46%. But if I do it on my calculator, I'll be able to get better numbers. 10. So this is about 55%, and this one is about 45%. So if I go back to my table, I can fill in this table by saying this is the females are 55% of this age group and the males are 45% of this age group. Now this is called a conditional distribution, and each one is called a conditional probability. Now if I want to find out the distribution of the conditional probabilities of getting 2 concussions, if I go back to my concussions, here it looks like there's 22. So 11 out of 22, which is 50%. And then 8 out of 22 is 36%. And then finally, non-athletes would be 14% of the people who had 2 concussions. Now, if we want to just look at, we're assuming that soccer players is true. So if we go back to just the soccer players, now we're just looking at this row. Now, as a total, there's 45 plus 25 plus 11 plus 10, or 91 total people in this column. So if I do 45 over 91, that's about 49%. 25 over 91, that gives us 27%. 11 out of 21, that gives us, or out of 91, gives us about 12%. And we can fill in the data from there. So we have 49%, 27%, 12%, and what's left over is another 12%. So these are the conditional probabilities. Now, in the future, we're going to be learning about these probabilities, and there's a way we write these. Well, if I wanted to find out one of these probabilities, like the probability we get 1 concussion, given the fact that we're a soccer player, we would write it like this. So the probability that we got 1 concussion, given the fact that we're a soccer player, is 27%. On this previous one, I could say probability that we have 2 concussions, give probability that someone is a non-soccer player, given the fact that they have 2 concussions. So they have 2 concussions. Of the people who have 2 concussions, 36% of them are non-soccer players. All right, that's just some notation that we'll see again in the future. All right, so displaying data of categorical variables. No single graph portrays the form of the relationship between the categorical variable. No single numerical measure summarizes the strength of that association. All right, now the next few slides are an example of a paradox. Here's what we're doing. We want to see if medical helicopters save lives. So they took some data, and of this data, helicopters, if someone chose to do a helicopter, they died 64 times, and when they survived 136 times. While on the road, it was 260 out of 260 died and 140 survived. So let's find the percentages of these, the conditional probabilities. So 64 out of 200, so this is 32%. And this one is 68%. Over here, this is out of 1,000, so this would be 26% and 84%. I wrote these in different notation. Let's just call these percents. All right, so from this data, you can see that people have a higher survival rate on the road. So somebody might think that it's a better idea to not use the helicopter at all. We can just use the ambulances. However, if we break that data down a little bit more, and we can see that we divide it into serious and less serious injuries. Now, when we do that, this is out of 100, so this would be 48% and 50%. These are also out of 100, so 40 and 60%. These add up to 100, so 16% and 84%. This adds up to 1,000, so that would be 20% and 80%. So when we divide it up, helicopters have a higher survival rate than an ambulance on serious injuries. Also, when we come to less serious injuries, helicopters also have a higher rate. So it's the exact opposite from the compiled data. So sometimes there are other variables that can actually give you the opposite result than the original result. So we call this Simpson's paradox. It's an association or comparison that holds for all of the several groups and it can reverse when the data is combined to form a single group. This reversal is called the Simpson's paradox. All right, hopefully that was good enough to get you through your homework. Good luck.